Hello, welcome you all to the world of operations research. This is a prescribed subject for the undergraduate program. Myself, Dr. Kumudavalli from Dayanand Sagar College of Arts, Science and Commerce, Bangalore. In this video, we'll be learning about few definitions which are the preamble for learning the simplex method. We actually bring the given linear programming problem into the standard form, and for that we really require two different variables called as slack and surplus variables. Let us understand what they are. And the basic steps that we follow in solving an LPP using the simplex method is nothing but the simplex algorithm. So the basic algorithm is also learnt in the video. The basic definitions are the first one is called the objective function. We all already know in graphical method we have used the objective function, that is our aim, either to minimize or to maximize. That is the main objective of the actual solving problem. So the function z equal to cx, that is cost, and the variables that we use together will be used to either minimize or maximize. So whenever we say that there is an objective function, the main target is to either minimize or to maximize, and that's called the objective function. And we have a set of real variables called x1, x2, x3 that depends on the number of variables that we have chosen for the linear programming. It should satisfy a constraint. That means we have LHS and RHS, and LHS and RHS can be expressed with a symbol maybe as less than or equal to or greater than or equal to. That means it can be an inequality or an equation. So the set of real values which really satisfies the constraints ax less than or equal to b, or ax equal to b, or ax greater than or equal to b is called as the solution. So we might get the solution whenever we have three types of constraints given to us. Similarly, a set of real values as mentioned x1, x2, x3 so on, which satisfies the condition that ax less than or equal to b, and also it takes care of the non-negativity constraint. That means to say the variables that are introduced, that is which we have x, is always positive. That's the meaning of non-negative. So if we have a solution where the variables are also concerned with the non-negativity condition, then it's called as a feasible solution. How we have made it in the graphical method that we get a region called as feasible region, same kind we can apply simplex method also to find the feasible region with a solution which satisfies non-negativity. And the next one is called optimal solution. We know whenever it is optimization, it is maximum and minimum, but to do this we undergo the same conditions as we have to first of all have a solution, and that solution has to be a feasible solution, and then we attempt to either maximize or minimize the objective function. So the definition would go like, we have the real values called x1, x2, x3 so on, which satisfies all the basic three conditions, that is ax either less or equal or greater than or equal to b, that is your RHS, and it also satisfies the non-negativity constraints. With that, it optimizes the objective function. We know objective function is z equal to cx, and when we say optimization, it is either maximization or minimization that is required. So these are some basic definitions that we really need to know before even we understand the simplex method. So what exactly is simplex method? It is just a iterative method. Iteration means the previous step, whatever we get the answer, will become the input for the next step that we are going to further consider. So the every step answer is considered to be feeding in as the input for the next coming up step. So it is an iterative method for solving the given LPP. We also know we had graphical method. There exactly we plot a graph and solve it, but in case of simplex method, every time we get a solution, we try to iterate it more for a better solution. This LPP takes a finite number of steps, and in order to solve this actual basic LPP using simplex method, we use, as I mentioned, two variables called as slack and surplus variable.